we're moving on to problem 21 from the AMC 10B from 2019. Deborah flips a fair coin repeatedly, keeping track of how many heads and how many tails she has seen in total until she gets either 2 heads in a row or 2 tails in a row, at which point she stops flipping. What is the probability that she gets 2 heads in a row, but she sees a second tail before she sees a second head? So, this is it's pretty well explained, but if you don't get it, so basically Deborah has a coin with 2 sides. It cannot land on the side of the coin, and she's keeping track of how many heads and tails. So we want 2 heads in a row, but she sees a second tail before she sees a second head. So what that basically means is that she does a tail and then a head and then a tail, or some configuration like this. Well, yes, it's the only starting configuration possible, because if you started with heads here and you alternated, it would either be heads, heads, or heads, tail, heads, in which you would see the second head before you would see the second tail. So it's at least this. We got the second tail before a second head thing, but we want 2 heads in a row. So it's like head and head. This is the least possible configuration, where each thing has where each flip has a 1/2 probability chance of landing on tails or heads. Since there's 5 terms here, this is 1 over 2 to the power of 5. And, well, this might seem strange, but this is literally just 1/2 to the power of 5, if it makes more sense. This is 1 over 32. And you might think that that's our answer, but that's clearly not. Because as you keep on going, or as you might notice, it just says 2 second tail before she sees a second head. It doesn't say there's a specified number of terms here. So in that way, we can technically keep on adding infinite. So once we have tails, head, tails, as long as it doesn't hit 2 heads in a row, we can add infinite heads, tails, until infinity. But at one point, it has to have heads, heads, but this goes on to infinity. So it can go on. It can go on to infinity. That's the main insight into this problem. Since the original probability was 1 over 32, and every new increment is a heads tail, that's 1/4 probability, we can apply that formula, the geometric sum formula, where it goes on to infinity. This is geometric series. 1 over 32 over 1 minus 1/4 is 1 over 32 over 3/4 is, this is gonna get our answer, 1 over 24. We are done.